Hey guys, today we're going to take a look at the rest of lesson 3.1. So we're going to start up here with our types of probability. The first type is classical or theoretical probability. This is when each outcome in a sample space is equally likely to occur. This is probability that you haven't done yet. This is just what could happen. So if you think about flipping a coin, there's two sides. So you have a 50-50 chance of getting heads or tails. It's just that what could possibly happen, not what has, it's what could possibly happen. So example 3, finding classical probability. You roll a 6-sided die, find the probability of each event. So the event of rolling a 3. On a 6-sided dice, there is 1 3. And there are 6 different ways that the die can land. So 1 in 6 times, you can roll a 3. And you can leave it as that 1/6. You can write it as a decimal, or you can write it as a percentage. Event D, rolling a 7. How many 7s are there on a 6-sided dice? There are 0. But there are still 6 possibilities, so 0 out of 6, which is 0 or 0% chance. Event E, rolling a number less than 5. So again, if we think about all of the numbers on a dice, there's 6. Number less than 5. Notice it didn't say less than or equal to, it says less than. So there's 1, 2, 3, 4 numbers that are less than 5. So 4 out of 6 gives us 0.667 or 66.7%. Another type of probability is empirical or statistical probability. This is based on observations obtained from a probability experiment. So this is no longer a theoretical, this is not what possibly could happen, this is what has happened. So we have this table over here. It's got the different responses, positive, negative, neither, and don't know, and then the number of times that it's happened, and then the total responses. So example 4 wants us to find the empirical probability. A company is conducting a telephone survey of randomly selected individuals to get their overall impression of the past decade. So far, 1,504 people have been surveyed. What is the probability that the next person in the survey has a positive overall impression of the 2000s? So positive, 406 people have said that. So the probability would be 406 over our total number of people. And you could change that into a decimal or a percentage, or you can leave it as that fraction. And then our last type is subjective probability, intuition, educated guess, estimations. So an example of this, a doctor may feel that a patient has a 90% chance of fully recovering. You might think you have a 70% chance of passing a test, things like that. The next thing we're going to talk about is something called the law of large numbers. As an experiment is repeated over and over, the statistical probability of an event approaches the theoretical probability of an event. So as you conduct an experiment, it gets closer and closer to that theoretical, that possible outcomes. So you can see this in the table right here, tossing heads or tossing tails. So if you just do it a few times, you might flip a coin and get 5 tails in a row. But if you do it many, many times, you're going to get that 50-50 spot. That's what I was talking about when we played our odds and evens game on the first part of this lesson. If we kept playing that game for like a whole day, that class average would get closer and closer to that 20%. Next, we have our range of probability rule. The probability of an event occurring is between 0 and 1. Okay, and that 1 is also 100%. So the closer you are to 0, the more unlikely, the more impossible it is. When you get into that 0.5, that 50%, it's an even chance. And the closer you get to 1, the more certain it is. Okay, so next we're going to introduce our next example that's going to talk about our last probability principle that we're going to talk about for this lesson. You are planning your outfits for the week. You have shirts that are red, green, and blue. You have pants that are green, blue, navy, and mint. So number 1, how many total outfits can you make? Go ahead, take a minute, try and figure that out, pause the video, and come back. So you could have created a tree diagram like this to figure out how many possible outfits you could make. So you can make 12. Red with green pants, red with blue, red with navy, red with mint. Same for the green and the blue. So you can make 12 outfits. Is there anything you notice about that 12? We have 3 shirts and 4 pants. And 3 times 4 is 12. That's no coincidence. That is our fundamental counting principle. The fundamental counting principle, if one event occurs in m ways and a second event occurs in n ways, then the number of ways that 2 events can occur in sequence is m times n. So let's look at 3. The access code for a car security system consists of 4 digits. Each digit can be any number between 0 and 9. How many access codes are possible when each digit can only be used once and not repeated? So for A, the first digit can be any number between 0 and 9. That's 10 digits. The second digit, we can't repeat a number, so there's only 9 left. Then we can't repeat any of the first 2, so now there's 8 left, and then 7 left. So according to our fundamental counting principle, for 2 events to occur in sequence, m times n, and that extends to however many sequences you have. So we do 10 times 9 times 8 times 7 to find out how many ways we can do that. Okay, hopefully you got a chance to try those problems. Go ahead and pause and check your answers. And here's 5 and 6.